Wow, 7 a.m. only. Wow, sian, so early morning, need to go to the office. Wow, bro, every day I come office see your face, yeah. But then, cash on.
No.
Wow, I wish I could work from home like the marketing teams there. Wow, look at them. They only need to come to office today. 1 day per week then. That's why they look so energetic and refreshed, not like us, yeah. Hey, you see this song? She's damn funny,
What you just say? Look at them, they're working so hard. Not like you all always complain here, complain there.
But boss, they only need to work 1 day a week. That's why they can work so hard.
What nonsense is this?
No, trust me, boss. Let me tell you why.
As you can see, the main objective of today's study is to figure out if implementing remote work arrangements increases productivity for employees. The shift towards remote work arrangement, accelerated by the COVID-19 pandemic, has raised questions about its impact on employee productivity. While many employees prefer working remotely due to flexibility and work-life balance, there is limited empirical evidence to determine whether such arrangements consistently lead to enhanced productivity across industries.
The central limit theorem states that the distribution of sample mean will become close to a normal distribution with mean and variance when the sample size n is large, which is 30 or more. Since our sample size is more than 30, we can apply the central limit theorem, and the distribution of our sample mean will become close to a normal distribution. Diving into our analysis, using the data we collected, we performed our hypothesis test and followed it up with a two-sample test. Here's what we hypothesized. The average productivity of working from home is the same as the average productivity of working in the office. So to put it simply, mu1 represents the average productivity of working in the office, and mu2 represents the average productivity of working from home. So our null hypothesis is that mu1 equals mu2, meaning that there is no difference between the two. On the other hand, our alternative hypothesis is that mu1 does not equal to mu2, meaning that there is a difference.
Now here's what we found. After running the test, the p-value came out to be 1.322 times 10 to the power of negative 5, which is a really small value. At a 99% confidence level, this gives us strong evidence to reject the null hypothesis. What's even more interesting is that our result shows that mu1 is not equal to mu2. In other words, we can see that from the data, the average productivity of working from home is higher than working in an office. So based on this, we can confidently say that there is a significant difference and we reject the null hypothesis. Now, let's move on to the next part of our study.
For regression analysis, we split it into two parts. To start, we calculated the skewness of the data, which showed that it is less than 1. This shows that it is not right skewed and log transformation is not required. Moving on, firstly, we did a regression analysis to see how the weekly productivity score may be influenced by the number of work from home days, hours worked per week, as well as the job role complexity. For this, we found that the adjusted R-square value was 0.3682. This shows that there is some positive correlation between the productivity and the independent variables. Overall, from this first regression analysis, we can conclude that as the number of work from home days increases, there is generally an increase in the productivity since the coefficient of the work from home days per week is positive and has a significant influence on the dependent variable.
To determine the optimal number of work from home days per week that maximizes efficiency, I ran a regression analysis using weekly productivity scores as the dependent variable and the number of work from home days per week as the independent variable. From the result, we can see that coefficient represent the expected change in weekly productivity when the number of work from home days increases. The significance levels indicate whether these differences are statistically meaningful. Looking at the output, the coefficient for 4 days per week is the highest among all levels. This indicates that working from home 4 days per week leads to a greater increase in weekly productivity. Additionally, the p-value for this coefficient is extremely small, denoting a very strong and statistical significance. This means that the observed relationship is highly unlikely to be due to random chance. In comparison, while 1, 2, 3, and 5 work from home days also show significant positive effects on productivity. The coefficient are lower than that of 4 days. This reinforces that working from home 4 days per week provides the highest productivity.
Next, we did a regression analysis on comparing the number of work from home days per week to team size, commute time, age, and job satisfaction score. From the second regression analysis, we could see that the coefficients for team size, age, and job satisfaction score are positive, with job satisfaction score being the most positive. However, it is important to note that correlation is not equal to causation, and so we cannot necessarily conclude that the independent variables directly affect the dependent variable.
Since it's more productive for you all, right, I will approve of the request to work from home.
Let's go!
Wait, but before I run off, there's a famous Chinese saying that I think relates specifically to this scenario. Let me recite it for you. 树何如汤米，旱地何虾土，岁之环中长，离力皆辛苦。
Work from home, work from home, work from home, work from home. What's going on? It's 7 a.m. only. Was it all a dream?
The woman was too stunned to speak.